Welcome to our review on burning hydrocarbons. First thing we need to understand then is what we're talking about when we refer to a fuel. So a fuel is a substance that's going to react with oxygen and release useful energy, and this is usually in the form of heat energy. So in order to actually make that fuel burn or to undergo combustion, then we need oxygen, and that oxygen usually comes from the air. If we've got a plentiful supply of our oxygen, then we will see a process called complete combustion happening. Okay, so when hydrocarbons burn completely, we make two things. We're going to make carbon dioxide and we're going to make water. The carbon atoms are going to react with oxygen from our air to make the carbon dioxide, and the hydrogen atoms are going to react with the oxygen in the air to make water. So remember, our hydrocarbon is made of carbon and hydrogen only. So obviously the carbon from it reacts with oxygen from the air to make carbon dioxide, hydrogen reacting with the oxygen to make our water. So you've got the word equation at the bottom there that shows you what's happening. And if you were asked to write a word equation in the exam, your question would literally give you everything you need to get the mark. So your question would be along the lines of, when methane burns in oxygen, it creates carbon dioxide and water. Write a word equation for this. So all you need to do is write down methane plus oxygen, put your arrow in, carbon dioxide plus water on the other side. It's a nice easy mark that everyone should get. In class, hopefully you saw a little demonstration about how we can test the products of complete combustion to prove we are making carbon dioxide and water. So in the diagram there you can see the equipment setup that hopefully you've seen in class. On the left hand side we've got our flame and a little funnel connected to a delivery tube that goes into our first test tube there, which has got cobalt chloride paper in it, and then into the second test tube, which has got some lime water in there. Now what we're going to see is, as that flame is burning, we are going to see our lime water going from the colourless to cloudy, and that tells us carbon dioxide is present, and the cobalt chloride paper is going to change from the blue colour to pink, which tells us that water is present. Last thing we really need to understand here is how to write balanced equations. So our first step is to write down the formula from the question into that typical equation format. So if you got a question like methane, CH4, burns in oxygen to produce carbon dioxide and water. Now you are expected to know some formulas, so oxygen, O2, carbon dioxide, CO2, and water, H2O. Learn those ones if you don't already know them. Then all we're going to do is read the question. It tells us methane is CH4, so write down CH4, and it's burning in oxygen, so plus O2. Put the arrow in, and it's going to make carbon dioxide, CO2, plus water, which is H2O. If you just write down the correct symbols, you will get one of those 2 marks, because if you've ever got to balance the equation, it's always worth 2 marks. If it's an already balanced symbol equation, it's only going to be worth 1, so all you need to do is write down the formula. So have a look at how many marks this balanced equation is worth. If it's worth 1, all you need to do is write down the formulas, because it will already be balanced once you've done that. If it's worth 2, you get your first mark for writing down the symbols. So always write the symbols down. Our second step then is to divide it up. So all I do is put a line down under the arrow to divide our reactants and our products. Then what we're going to do is count the number of each element on each side of that line. So we've only got the 3 elements in this one, carbon, hydrogen, oxygen. So just put C, H and O down and then count up how many there are on each side. So if we looked at the left hand side first of all, our reactants, we can see there is 1 carbon. We've got 4 hydrogens, because remember the little 4 to the bottom right of the symbol tells us that there's 4 of that element, and then 2 oxygens because of the little 2 in the bottom right of the O. Looking at the right hand side, we've got 1 carbon, we've got 2 oxygens in the carbon dioxide and the oxygen in water. So in total we've got 3 oxygens there and the 2 hydrogens. So if you write those down first of all, then we can see what matches and what doesn't match. Our third step then is to add numbers in front of the chemicals to multiply up the number of each element until we've got both sides balanced. Now, where we've got those red bits, that's the only place we can put numbers. You can't put them anywhere else when balancing. So, what we already know is our carbons are already balanced. So if we look at our hydrogens next, on the left hand side we've got 4, and the right hand side we had 2. So to balance it, what we need to do is put a 2 in front of our water. So you can see I've put the red 2 in there to show you that. And then we're going to have 2 times 2 for our hydrogens, gives us 4, and 2 times 1 for oxygen, but don't forget we've got 2 in carbon dioxide, so that gives us 4 oxygens on the right as well. Next one we need to look at then is how we can get our oxygens the same, because as we could see on the previous slide then, we've got the same number of carbons, the same number of hydrogens, but on the left we had 2 oxygens and on the right we had 4. So to balance that, all we need to do is put a 2 in front of our O2, our oxygen, because 2 times 2 gives us 4. Then we can see that all 3 elements have got the same number on the left as they do on the right. And that's all you need to do to balance those equations. Just remember that even if you really aren't any good at balancing, just by writing down the formulas in that equation, then you will get 1 out of the 2 marks.